All right, so let's go over the questions from the second form of the test. First of all, this first question, 2g plus 2, the 1/2 power minus 10 equals 2. We need to isolate the 1/2 power, so we're going to add 10 to both sides first. So 2g plus 2 to the 1/2 power equals 12. In order to get rid of the 1/2 power, we're going to raise it to a power of 2 whole, add to both sides. So 2g plus 2 equals 144. Minus 2, so 2g equals 142. Divide by 2, g equals 71. Question 2. We need to isolate the cubed root, so minus 5. So the cubed root can also be written as cube plus 3 to the 1/3 power. 7 minus 5 is 2. So we're going to get rid of the 1/3 power by cubing it. So cube plus 3 equals 8. Minus 3, so q equals 5. Okay, the vertical asymptote can be found by taking your denominator and setting it equal to 0. So x plus 9 equals 0. The vertical asymptote is where x equals -9. If we are using an inverse variation, we use the equation y equals k over x. Y is 14 when x is -2 is the pair. So 14 equals k over -2. In order to get k, we're going to multiply both sides by -2. So -28 equals k. Now we're going to use that, so y equals -28 over x, to find y when x is 7. So y equals -28 over 7, so y equals -4. All right, if y varies directly, we're going to use the equation y equals kx. This is the pair. Y is 12 when x is 4, so 12 equals k times 4. Divide both sides by 4. So 12 divided by 4 is 3. So k is 3. So y equals 3 times x. If x is 6, y equals 3 times 6, so y equals 18. All right. If we're going to solve the system, we're going to use substitution. So if I know y is equal to all of this, I can put it in place of this y. So 2x plus 1 equals x squared minus 5x plus 7. We're going to move everything to one side. So 1 equals x squared minus 7x plus 7. Oops, my bad. 0 equals x squared minus 7x plus 6. So if I factor that factors into x minus 6 and x minus 1. Solve them. All right, now a lot of you stopped here, but if we're finding the solution to a system, that means we're finding the ordered pairs where those two things would cross each other. So if I'm finding an ordered pair, I need to find the y values tied to those x's. So if we know y equals 2x plus 1, then we know y equals 2 times 6 plus 1, so y equals 13. So one of my answers is the ordered pair 6, 13, and the other, so hang on, y equals 2 times 1 plus 1, so y equals 3. So my other ordered pair is 1, 3. Number 7. All right, so what we have to do first is we have to change this log equation to an exponential. So 8 to the x power equals 3. Now, if you can make 8 and 3 the same base, then you could solve the exponents, but I can't make 8 and 3 the same base. So instead, we're going to take the log of both sides. That allows us to take the exponent and pull it down in front. So we have x times the log of 8 equals the log of 3. So in order to get x, we're going to divide by the log of 8. So the log of 3 divided by the log of 8 is 0.528. That's approximate because the decimal is longer. Number 8. In order to add these fractions, in order to solve for r, we need to first get all of the fractions to have the same denominator because we're dealing with an addition sign. So we're going to factor this one that can be factored. So this is r minus 8 times r minus 2. Okay, now that is the new denominator for this fraction, and I can change all of the others to the same denominator. This first fraction already has an r minus 2, so all I have to do is multiply r minus 8, and then it would be the same, but I need to do that on top also. This last fraction already has r minus 2, so I need to multiply by r minus 8. So now I have r minus 8 times 1 is r minus 8 over r minus 8 times r minus 2 plus 1 over r minus 8 times r minus 2 equals 3 times r is 3r. 3 times negative 8 is minus 24 over r minus 8, r minus 2. So now that all the denominators are the same, when we're solving, we can pretend they're not there, because if they're all the same, all we have to do is make the numerators the same. So if I know r minus 8 plus 1 equals 3r minus 24, negative 8 plus 1, so r minus 7 equals 3r minus 24, add 7, so r equals 3r minus, 17. Now we're going to minus 3r, negative 2r equals negative 17, divide by negative 2, so r equals 17 over 2. Number 9, if I have x minus 5 squared, then in order to get rid of the squared, I'm going to raise it to the 1/2 power, which is the same as taking the square root. Because I started out with an x squared, my square root of 4 can be 2 or negative 2. So I have x minus 5 equals 2, and x minus 5 equals negative 2. So add 5, x equals 7. And the other answer, x equals 3. Example 10. I told you when we were multiplying rational expressions that you're not really multiplying anything. Instead, multiplication means that you can write it all as one single fraction. So on the top, I have x minus 8, 4x, and x plus 10. On the bottom, I have x plus 6, x minus 8, and x plus 10. And then you're just going to simplify the fraction. So I have a factor of x plus 10 that can be factored out. X minus 8 can cancel out. So I have this fraction where all I have left on top is 4x, and all I have left on bottom is x minus 6, and there's nothing else I can do with that.